This is Algebra 2, Unit 2, Lesson 5 on one-to-one functions. Functions as rules can be divided into various categories based on shared characteristics. One category is comprised of functions known as one-to-one. So let's see what one-to-one actually means. We're going to look at a function that is one-to-one and one that is not. All right, now think about what one-to-one means when we're going over this and see if you can figure out what the difference is. So we have two simple functions, f of x equals 2x, and we have g of x equals x squared. All right, for part A, it says map the domain -2, 0, 2 using each function. Fill in the range and show the mapping arrows. Okay, so first of all, let's review. What is a domain? Those are your inputs, or your x values. So your inputs here, you want to find the outputs using -2, 0, and 2 in each function. So for the domain of f is -2, 0, 2, the range, you would use f of x equals 2x. So -2, 2, to find that, it would be f of -2. Plug in -2, 2 times -2 is -4. All right, 0. So to find 0, f of 0, 2 times 0 is equal to 0. And then for 2, your mapping would be f of 2, 2 times 2 is 4. Okay. Now, we would do the same thing for the domain of g. All right, if we use g of x with the values -2, 0, and 2, -2 into here would be g of -2. That's -2. -2 squared is 4. G of 0 would be 0 squared, which is 0. And g of 2 would be also 4. So I'm not going to list the 4 second, because we already have it there. I'm not going to list it again. Now, if I draw my arrows here, -2 becomes 4, 0 is 0, and 2 becomes 4 as well. Okay, so is this a function? First of all, are these both functions? Does every x have only one y? Yes, it does. Does every x have only one y? Yes, it does. Even though we're repeating the y, that's okay. It's just each x has its own y, and that's fine. Okay, now, what is fundamentally different between these two functions in terms of how the elements of the domain get mapped to the elements of the range? All right, so in each domain, in this one, how many things does it map to? It's only mapped to one thing. For g, each element in the domain is not mapped to each single element thing. It repeats a range, which is okay. It's a function, but is it one-to-one? So each domain for f of x is mapped to a single element of the range. No outputs are repeated. All right, so if you think about what one-to-one means, f of x is one-to-one. A one-to-one function. G of x is a function, but it is not one-to-one. Each x has its own y, but it does not have a unique y. All right, this one, each x has its own y, each x has its own y. Each x has a y, but it's not unique, because -2 and 2 have the same y. It's still a function, but it's not one-to-one. So the formal definition of one-to-one is this. A function f of x is called one-to-one if x1 does not equal to x2, so the x's aren't repeated, and it implies that f of x1 is not equal to f of x2. The y's are not repeated. So if the x's aren't repeated, the y's aren't repeated. That makes it one-to-one. In other words, different inputs give different outputs. Each x has its own y that is unique. So each x has a unique y. So let's see if we can pick out the one-to-one function. Of the four tables below, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. Okay, so first of all, in order to be a one-to-one function, first of all, it has to be a function. All right, is number 1 a function? No, it's not a function. All right, it is not a function because the x values repeat with a unique y. All right, it has repeated x's with different y's. So it's not a function to start with. And so we don't have to worry about it being one-to-one if it's not a function. Okay. So this is not. This is no. Okay. All right, number 2. We have -2, 1, -1, 0, 0, 1, and 1, 2. Is this a function? It is a function because the x's don't repeat, but is it one-to-one? It is a function because the x's don't repeat, but is it one-to-one? Well, let's see. -2, 1, -1, 0, 0, 1, 1, 2. Notice right here, we have the two values that are repeating. So, because the y's repeat, this is not one-to-one. This is not a one-to-one function. Okay, how about number 3? We have 1, 2, 2, 4, 3, 8, 4, 16. Is this a function? It is a function. Now, does each x have its own unique y? 1 becomes 2, 2 becomes 4, 3 becomes 8, 4 becomes 16. Yeah. So this is one-to-one because each x has a unique y. All right. And for number 4, is this a function and is it one-to-one? First of all, is it a function? No, because the values repeat. So the x values repeat, so this is not a function. For the same reason on number 1, back here. It has repeated x's. So this is not a function, so we don't have to worry about it being one-to-one. And actually on this as well, the y's also repeat. The y repeats here and here. So this is not a function and it's not one-to-one. Okay, now we want to look at figuring out if the function is one-to-one graphically. Now we already know how to figure out if it's a function using a certain test. Let's look at these. Consider the following 4 graphs which show a relationship between the variables y and x. Circle the 2 graphs above that are functions. Explain how you know they're functions. All right, first of all, how do we know they're functions? Well, for every x have only one y, what do? The vertical line test. If we draw a vertical line and we hit the graph only once, makes it a function. So if we do the vertical line test on these, which 2 graphs are functions? Well, let's see. If I draw a vertical line here, it hits it only once. All right. Here, I hit it multiple times. Here, I hit it multiple times. And here, I hit it only once. So which ones of these are functions? Well, it would be number 1, because it hits it only once, and number 4. So those are functions because when you draw a vertical line, it hits the graph only one time. For each x, there's only one y. Okay, now, of the 2 graphs you circled, which graph is one-to-one? And explain how you can tell from the graph. All right, so we're only going to look at number 1 and number 4. All right, so remember for one-to-one, each x has to have a unique y. So are any y values repeated? Well, let's see. Which one of these is one-to-one? So this is right here. If I draw or figure out my values here, are any y values repeated? Yeah. I'm going to draw a different line. I'm going to draw a horizontal line. Let me do a different color so you can tell which one I'm drawing here. Okay, if I draw a horizontal line right here, this x, whatever it is, has this y, and this x over here has this y. So is this one-to-one? No, this is not one-to-one. All right, so on this one, if I draw a horizontal line and try to hit the graph, wherever I draw this line, I'm only going to hit the graph once. So number 4 is one-to-one because there are no repeating y values. Okay, so what I just did is what's called the horizontal line test. So the horizontal line test says if any given horizontal line passes through the graph of function at most one time, now there's the key word right there, at most one time, then that function is one-to-one. This test works because horizontal lines represent constant y values. Hence, if a horizontal line intersects a graph more than once, an output has been repeated. So, when you have a horizontal line test, you have to figure out whether or not it hits the graph more than once. If it hits the graph more than once, it is not one-to-one. So, knowing that, see if you can figure out for exercise 4 which one of these is a one-to-one function and see if you can tell me why. I'll ask you about that in the next class. All right, and we're going to do also some exercise 5. The distance that a number x lies from the number 5 on a one-dimensional number line is given by the function d of x equals the absolute value of x minus 5. Show by example that d of x is not a one-to-one function. Okay, so for this one, see if you can find values of x that will give you the same y. Show me an example of why this is not a one-to-one function. So show me if you plug in what x's will give you the same, two different x's will give you the same y. All right, so that's your assignment for tomorrow. See if you can figure those out. We'll go over them in class in the next class.